all mixed. So when you guys get into the test review, you'll get to go back to, hey, take d dx of both sides. And don't forget, if you take the derivative of y squared, it's going to be 2y dy dx. And you'll also maybe face some second derivatives implicitly, where you have to take a derivative of a derivative, and then you're going to end up with a little dy dx in a nasty spot. You're going to have to substitute and then simplify. Then you're going to go to section 2.6, where you had to, 2.6a, where you had to find f inverse prime of b. Ooh, do you remember that derivative rule? F inverse prime of b equals 1 over f prime of a. Hey, is that a forever card? Good thing the test is on Thursday, or else the forever quiz would have been today. I announced it last week, and I forgot to remind you yesterday. Good thing I moved the test, because then the forever quiz wasn't today. The forever quiz is going to be tomorrow. How many forever quiz cards? One of them is f inverse prime of b over f prime of a, and there's a little note on that one. Check out that card. And then what's the other? 2.6b. What's the other forever card? Yeah, derivative of sine inverse, derivative of cosine inverse, derivative of tangent inverse and cotangent inverse and secant inverse and cosecant inverse. But the nice thing of that, don't you just have to know the rules? And as long as you know the rules, don't forget that with every u, you just need to multiply by a u prime, right? Don't kill bunnies. That was 2.6b. It was kind of a nice reprieve in that, hey, there are these new rules, use them. Okay, but how does 2.6b get hard? The only time it'll get hard, as long as you know your rules, is if some sort of trig fact comes up. So you might need to review your unit circle before the test. And then section 2.7. Okay, so the test review lets you kind of take a break from related rates, so take that tonight. Go work on that test review, have it ready at 7 a.m. tomorrow so we can go over questions to the test review, and then I do have a practice test ready. The practice test itself is posted. It's shorter than normal just because there is a lot this chapter, and related rates take time, so it's a lot shorter. Like 3 indicative multiple choice from like every single section, just like, hey, this is what multiple choice could look like. There's a, hey, this is what long answer could look like. I think there's 2 of them. And then I even threw in an AP FRQ that has to do with related rates. I will get the answer key posted in there in Google Classroom. I'm hoping today. Sorry, juggling a lot at the beginning of this week. Besides that, you guys have test corrections that can get you points back for the end of the grading period. I think right now your grade is at the worst case scenario as far as the score as is from chapter 2, right? Have you guys noticed that? I think that score as is in your RenWeb. So what's going to help when you turn in the corrections? Right? You'll get a little bit higher, hopefully, as long as you get those corrections done. I will not be putting chapter 2B test on this grading period. Okay? You'll get it in, you'll get it done. That's good. But I will just put in the corrections to let your grade be a little like, unless you haven't been doing homework, then get those into Google Classroom and post me comments. If it was a 0, was a missing, you're like, I did it now, it's in there. You have to post me a comment so I can get an email notification and go check it out. Some of you guys got behind on homework somewhere. But I will get those corrections in to let your grade kind of settle. And then I'll be grading the test chapter 2B, but I'll put that grade in after like the grading period deadline thing next Wednesday cuts off. Okay, I think logistics, we're good. Any logistical questions, or can we just work for the rest of class? We're okay? Okay, what are you going to do if something doesn't make sense in class today? Please ask. If you don't understand a step, ask. Okay? You've tried, you've struggled, I'm going to try to answer. Stop me if you're like, but I don't, because you need to be able to make the connections. Are we cool? Okay. Let's start with number 20. Let's start with number 20. It's a tricky one, and there's a definite trick to it. It's a trick that actually shows up in the shadow problem also. It's a trick that shows up in the shadow problem also. So number 20, it is an even. So how many of you guys right now say that you don't have an answer to this? How many of you guys would say for number 20 you don't have an answer to it? Okay, that's what I figured. How many of you guys went to Slater and tried to have that help? Okay. Did it help at all? Okay. Slater, sometimes it does help, and it depends on your brain, number 1. It depends on the quality of the solution that was offered. I usually don't like them, so that's why I was just checking to see if it did actually help or not. So let's go ahead as the book is coming up so that we can access your other questions once we get there for evens and odds, probably starting with odds and then going to evens. Let's go ahead and talk about number 20. We want to figure out the given. All of this stuff. The container, the trough, the thing that it's going in, has 12 feet depth and 3 feet across and 3 feet height or altitude. So maybe you can figure out what that was. So 3 feet altitude, 3 feet across, and 12 feet. But that's the container. What are we talking about for the problem? The water. Okay, so figure out what's going on with our find. Even though they gave all this information, that's all well and good. However, if you guys notice, I'm going to actually label up here. It's awkward they labeled it back there. I'm going to label H for height of the water because as the water comes in, isn't H changing? I need it to be variable, right? I'm going to label this guy to be the base. Why am I calling it base if it's actually high? I'm thinking about a triangle. And what's the area of a triangle? 1/2 base times height. And how do I get volume from the area of a base? I do 1/2 base times height times width, depth, whatever you want to call it, but times that third dimension. So if you were taking the area of a cylinder, it's pi r squared, what the base is times the height. If you were taking the area of a rectangular prism, it's base times height times depth, or length times width times height. This one's awkward because it's on its side. If I was to put it this way, most of you would like it a little bit better, but it is 1/2 base times height times depth as far as the volume. Why am I going to I made that a variable, I made that a variable, I made that a constant. How come? As the water goes up, what's the one thing that's not changing? The 12. It's constant, so I can do that from the very beginning. That's just me labeling my picture. Why did I label my picture? Because I need to go ahead and figure out d box d theta. They almost always give me something. And they're almost always asking for some sort of given thing on the boxes. So to go ahead and check out letter A. Water is being pumped into the trough at 2 cubic feet per minute. So that's my given, 2 feet cubed per minute. There are two ways to think about this. The easiest is probably, hey guys, what's measured with cubic units? Volume. Oh, hey, that's a dVdt. Oh, figures, they didn't say volume. No, but they talked about a three-dimensional quantity, water being pumped and changing the three-dimensional dimension of the water. It's talking about volume if it's filling up. It's talking about volume if it's filling up. That's dVdt, whether by looking at the feet cubed or whether by thinking about, hey, volume is changing as the water comes in. But then they say how fast, it's an unknown. They don't know. How fast? How fast is what? The water, now it does say water level rising, but did your brain look at the picture and say, oh, that's the height changing? Does that make sense? They said level. Height. Oh, wait, we don't know what it equals. So what do I do? Such that what? Depth or level is 1 foot. Any dimensional analysis or am I good? Feet with feet, I'm good. Feet with feet, I'm good. Well, wait a minute, I need a formula. We just talked about it. We have our given and find. 1/2 base times height. Where am I getting this? Area of a triangle. And what do I need to make it into the third dimension? Depth. And what did I say is not changing? 1/2 base times height times depth. So I could go ahead and say easy. It's all well and all. And if you remember from yesterday, we have two ways of going. We can take the derivative right now using product rule, or we can look ahead and say, uh-oh, I don't like one of these guys, and he's going to cause me problems, and try to rewrite before deriving. Deriving, we have to do a product rule. 6b could be one, and then h could be another. But can anybody look ahead and say, wait a minute, from this stuff, I don't like who or what. What's going to cause me trouble? B. Because I don't know anything about B or dBdt, and I don't need anything or want anything about B or dBdt. All I want is B and H. So here's the crazy geometry thing. Remember, if you're missing something, Go back and reconsider. What's the one thing we haven't really used? Why'd they tell me 3 across and 3 up for the container? If I were you, maybe in your notes, or maybe in your homework in a colored pen, I would make a quick note about similar shapes from geometry. Similar shapes have proportional sides. Similar shapes have proportional sides. What does that mean? Similar. Do you guys remember what similar is? It's not congruent. Congruent, everything's the same. The sides and the angles. What's true about similar? Only the angles. Sides can be different. So what's similar? How about this big triangle? What's similar to the big triangle, the triangle formed by the container? The little one, whatever the water level is. Their sides are proportional. Ding, 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 ding. Hidden clue. 3 over 3 is equal to B over H. Wait a minute. If the container says that the base is equal to the height, guess what's going to be true of every similar triangle that the water forms along the way? Base is equal to height. Now, if it wasn't equal, we'd set up a little proportion like this and we do cross multiplication, but 3H equals 3B, B equals H. We can actually say, oh, hey, because of the container, I know that B has to equal H with some algebra. Multiply, multiply, divide by 3, or just reduce. That's 1. Multiply, H equals B, B equals H. Every little similar triangle formed by the surface of the water, wherever it's at, the B is going to be the H because water conforms to the container it's put in. How does that help? Oh my goodness, it makes a world of difference, because what can we do over here now? Substitute. Now technically, is that a clue as in a such that? No, so maybe I shouldn't make it a clue because I tell you guys to ignore clues. Maybe it's better just to say like, hey, come over here and I can say, well, I want the B anyway, so let's go ahead and plug in and say, oh, wait a minute, isn't B the same thing as H? Yes, and if B is the same thing as H, what's another way of expressing my volume formula? Now go to your derivative. Now go to your derivative, just trying to keep it like the table that I showed you guys in class. So your derivative would be, hold on, pause. Are we okay with taking derivatives? What do we do to both sides? d dt, right? It's implicit differentiation because we're just deriving both sides as is. But does it match up? Or do we have to worry about u primes? Meaning, what's the derivative of v? 1 times v prime. Who's v prime? Are we okay with that? If not, this is going to be a really sad section. Derivative of v is 1 dv dt. Okay, what's the derivative of 6h squared? 12h times, good, take the derivative of the outside, that's why it was 1. It was 1 times dv dt. And 12h times, as you guys said, h prime. Because we dealt with the b early, are we nice and ready to plug and chug? Yeah. So plug and chug, dv dt. Oh, I know that. That's 2. You can make it feet cubed per minute, but we already checked that our units match up. If one was inches, one was feet, then we'd be in trouble. But otherwise, we're all right. 12 times h. Isn't that part of the clue up there? Now I can plug in. Now I can go back and say, oh, h is 1. dh dt, oh, no big dealio. I need to solve for him anyway. He's going to stay unknown until I get him alone. So at the end of the day, dh dt is equal to 2 over 12 is 1/6. What are my units? If height is the person whose rate I'm finding with respect to time, what's height measured in? Feet. And then time is measured in minutes. Double check. It's per minute, right? Does it say anything about how I have to do it per second? Because if so, I'd be in trouble. Nope. So feet per minute is good. If it said per second, I'd build a bridge. I'd build a bridge. Questions? Are we okay? What was the clue that most of you didn't realize? The BH. And where could some of you have gotten stuck a little bit earlier? The geometry. The geometry of a triangular prism. But do you realize where I got the formula from? 1/2 base times height was the surface or was the face, and then I had to multiply by depth. I got to plug in 12 once again early because constant, not changing as the water rises. So what's going on with letter B? Hey, can't I use everything I just had? Just what changes? What's my given now? Same trough, just things change a little bit. Yeah, I'm given water rising at a rate of d who dt? Good, dh dt, because the water level is changing at 3/8 inches per minute. And hopefully you guys realize inches couldn't be a dv dt anyway. And what are they asking for? Rate at which the water is pumped in. What was that measurement again? Yeah, d what dt? dv dt, the volume of the water changing, such that, can I still use for this same trough, this same formula of v equals 6h squared? Yeah. Can I still use this derivative? Yeah, just what's different for letter B? Oh, I don't know that, and I do know this, and I do, it's just a plug and chug. It's just a plug and chug, okay? That was number 20. That was number 20. I'm going to go ahead and quickly go through the even answers. Am I going to go through in a way that you guys can? No. So I'm going to point to the answer, and if you don't have that answer written down, somewhere off to the side in a colored pen, write the answer down. Maybe you'll have time to do the corrections because someone will ask it in class. Maybe it's something you'll work on again tonight and tomorrow, as we have basically part 2 workday, where we'll be going over questions to the review. If we have extra time, we can also go back to related rates. Or maybe it's something in the 0 period or after school you can ask. But let's get the answers down. So 6A, 24/25. Or if you simplify, that's okay, but you have to make it match eventually. Just make sure you're right. I'll put it that way. Make sure you're right. I'll put it that way. 24/25 inches per second. Letter B is 0 inches per second, and letter C is negative 24/25 inches per second. You guys can still kind of see. Number 4, down to A and to B. You had to use the volume of a sphere and take the derivative and plug and chug. This is on the video. If you need it, you can refer back to it from today. 2/9 pi. You can check the math that led there. Centimeters per minute. Make sure units. If you're not putting units, colored pen. Miss points if it's a long answer. 2/9 pi centimeters per minute. And then 1/18 pi centimeters per minute. The nice thing of a lot of these problems is the A's and B's are just plugging in different information. The math shouldn't really change too much because you're using the same scenario, the same original formula, hopefully the same derivative. The clues don't change too much most of the time. Number 20 we just went over. But if you want, the first one we already know. The second one ended up being or ends up being 3/4. Why feet? Volume. Good. Feet cubed per minute. That's volume. Remember, on evens, you're okay. If you can see here, it's right. Just count it right. You don't even need to simplify. Evens can be your practice of making it match. Number 28. That was the Pythagorean theorem one. How'd they plug in 90? Like the example we did in class, that constant. The player runs from, what's he running from, first to second? As a player runs from first to second, the distance from home to first isn't changing. He's over here, so his distance from and to the plates is changing, but not this. So they plugged in the constant early, took the derivative, plugged in chug some clues. They had to go back and use Pythagorean theorem because they knew one. They had to use Pythagorean theorem to find the other side and then plug and chug. Decimals, you guys know 3 decimal places, not 2. That's garbage, but you can still see if you were right. 15.35 feet per second. Letter B is a little bit weird, but letter B is just taking the derivative of y minus x. They changed up the scenario just a little bit. The derivative of y minus x is just dy dx dt. They plugged and chugged and just got 10/3. Number 44. Final answer B. I have those in the notes. Answer B, and then 45, you guys already know what final answer for 45. It was an odd D. Let's jump there just because those are multiple choice. Oh, hi. You're just mad. Okay, cool. Number 44 and 45, you might have some questions on those. Does anybody have a question on 44? Anybody have a question on 45? Okay. So not too many, so I'm not going to take tons of time, but I will peek at it for a second. Number 44, is this area of an equilateral triangle, is this like a formula we know off the top of our heads? No, which is why they gave it to us. The AP is kind of nice sometimes, as our book is trying to model and be like. The AP is kind of nice sometimes because like, that's a really abstract, random, out there formula. The point isn't necessarily, sorry, the point of the homework isn't necessarily to take off tons of points if you don't remember geometry in some random formula you might have seen once upon a time. So they gave you the formula. So that formula they gave you, you didn't even have to stress about the geometry. You could just say, oh, hey, by the way, that's what I'm supposed to use, aka area equals pause. Where's the square root end? Or what's the square root over? Just the, not even the s, just the 3. So a few of you guys might have made a mistake because you put the square root over the s squared also, and it's not supposed to be. So if I were you on this one for number 44, when you went to take the derivative for that step, I would have rewritten this guy to be square root of 3 over 4s squared, because square root of 3 over 4 is just a constant. So you could have brought down the 2, kept the square root of 3 over 4s, or if it's a little bit easier, you could have kept the root times 2s ds dt, and then plugged in for there. Just a few of you guys might have gotten stuck on taking that derivative. What was your given in your find if it said that the sides are increasing at a rate of, who's this guy? Centimeters per second? D who dt? It said sides. It said sides. So Michael, you were asking earlier about like how do you know what to put in the, so if it said at a rate, that's the d box dt, and who went in the box? Well, whose rate? Sides. So s goes in the box. So ds dt. What are they asking for? At what rate? Oh, that's just d box dt, right? What rate is the who? Do you see how I'm filling in to label stuff? Pause. Stand up, turn around 2 times, give someone a high five. Just one person a high five. 10 seconds. 9, 8, 7, 6, 5, 4, 3. Give someone a high five. 2, 1. Okay, grab a seat. I know. I know. And then what's my such that? 4. You guys should be fine to make it match with what the correct answer is, which I believe is letter B. Yeah. Letter B. Number 45. Like questions on that one. Number 40. More people had questions on that one. I'm drawing a cylindrical tank because that's what they said. A cylindrical tank has an R and has an H and has a volume formula of V equals pi R squared H. If you were to take the derivative right now, d dt of both sides, what rule would you have to use? Chain rule with like the dB dt and the dr dt dh, but don't you have to use the product rule too? Ugh, I really wish there was some sort of clue that could help me not have to keep both r and h in to derive. Is there a clue? What did they tell you about the dimensions of the tank? A diameter of 3 and a height of 6. Thomas is noticing that the water that's inside, as it's dropping, it must be leaking out. Changing. Volume is changing. What's not? R's not. But hold on, R's not. What's R? So therefore, before I take the derivative, why don't I go ahead and say, oh, hey, R's not changing. And R is 1.5, or 3 halves squared. Ha-ha! So now I have this constant of 9/4 pi h. Am I just going to be able to go to the derivative of dv dt is equal to 9/4 pi dh dt? And if you try to do product rule, second d first, derivative of any constant is 0, plus first d second dh dt. Plug and chug, cool kids, plug and chug. and you've got it, okay? Okay. But you guys were talking about other questions that you had in homework. So give me an odd. Give me an odd that you tried, you were able, or you had time to talk with your group and you're still stuck on. Michael.
17.
Perfect. Let's peek at 17 then. Number 17 gives us, or I should say the situation of number 17 is a sand and gravel plant. What on earth? Why is the book talking about a sand and gravel plant? Because an AP question, an FRQ on an AP test 4 years ago, talked about sand going on a conveyor belt onto a conical pile at a plant, at a gravel processing plant. Guess what some kids, especially kids for whom English wasn't their first language, guess where they got stuck? What's a gravel processing plant? What's going, like they just didn't know what was going on. It's weird, right? It's random, like gravel processing? Okay, that's weird. Who cares? What's the math? There's a cone. And what's happening to the cone? It's getting added to. If they're falling off onto a pile, what's going to happen to the pile? It's going to grow. Who cares about sand, gravel? I don't care. Cone, it's growing. The cone is going to have a radius and it's going to have a height. True? Okay. And then what happens as the size grows? That's not area, that's volume. Okay, so let's check out what's going on. Sand is falling off a conveyor and onto a conical pile. What is that like? Water is flowing out of a pipe and into a tank. Super similar. Super similar. So I can say for my given, wait a minute. Couldn't this have helped if I just thought about how it's feet cubed? Right? Feet cubed per minute. What should I think about feet cubed? Volume. So d who dt? dv dt. Are we okay? Cool. What's my find? Where's the question mark? At what rate is the height? So d who dt? Is there a such that? When the pile is... Are we okay with labeling stuff? Because if you have this, you're like, well, I need a formula with V and with H. Ooh, what did we miss? This is what the back group, you guys were talking about this clue, right? What did we miss? Diameter of the base of the cone is approximately 3 times the altitude. What was altitude, Michael, when you looked it up? Oh, sorry, what's altitude? Yeah, good. Diameter, height. That's some sort of random. Okay, cool, that's fun. Think ahead if we take a derivative and have to do a product rule. It's the only way to take a derivative right now if we go straight there. We're going to have a dv dt. We're going to have a second d first with a dr dt plus a first d second with a dh dt. Who don't I mind having? Or who don't I want? So either you take the derivative with the dr dt and then go, you think ahead and say, I don't want a dr dt. Wait, isn't r related to d, diameter? What is diameter and radius? What's that little baby formula? So can't I say that r is equal to 3/2 h? What can I do before ever taking a derivative? Get rid of r. Before I ever take a derivative, I could plug in and say 1/3 pi. Remember, there's information there. So if you don't want a dr dt, if there's not anything to plug in for a dr dt, they've given you a clue, or geometry, similar shapes. There's inherent to the problem a clue. Well, let me either substitute out the variable that I don't want to have differential, or when I do take derivative and I'm like, who's dr dt? I could come here and plug that in. Substitute now or substitute later and take a derivative first. If I substitute now, I get 3/2, which ends up being v equals, sorry, that's going to be 9/4, but that's going to reduce to be 3/4 pi h cubed. Go ahead and in my chart of what I'm doing, sorry, picture, given, find, there we go, and now take the derivative. dv dt, guys, I know how to take the derivative. Do you? How do you take that derivative? Of the other side. Can we bring down the 3 and make it a 9? Is that okay? I didn't hear people saying 9. H squared times. Guys, you have H, you have dv dt. You'll solve for dt. You're done. You're done. Is it hard? No. But is it hard to get started? Yes. What do I think makes all the difference? Being able to properly translate your clues, having a formula to go off of, and then thinking ahead and saying, oh, I don't have a dr dt. Pause. You could go with the percentage rule and then get stuck, or you could actually look ahead and say, oh no, okay, I missed something. There's a clue, it tells me R, I can get terms. The name of the game, if you're missing something, is there's some sort of substitution. Maybe it's a constant, like the 12 depth of the trough. Maybe it's a constant that can plug in, whose rate is 0. Or maybe it's a clue that you need to go back and consider, either from geometry or literally from the words. Do we have another odd that we want to look at? I know. Evens, but some of you need to take time with the answer key on the video with the evens before you're ready to ask a question. Any other odds? Rachel? 21. Number 21. Is the shadow problem an even or an odd? It's odd? Okay. I was surprised we hadn't gotten that one yet. Okay. On number 21, we have a ladder that's falling. Kiddos, what's your goal tonight? Real quick, because we're going to pretty much work to the bell. What's your goal tonight? Yeah, maybe finish related rates, maybe go over the evens and figure out what questions you have. But also for tomorrow, 7 a.m., what's your goal? But I'm also just giving you the practice tests, just in case. 1, 2, 3, 4. Some of you might want to play with it today during some classes to review what the topics are. I have a few people that are bored that have had the review done for a day or 2 or 3 or 4. Not very many. It's like 1 or 2 kids that have been begging for the practice test. So I'm giving it to you guys today. But this is not due until when? Test day, Thursday. Test day, Thursday. It's super short. But your goal for tomorrow is the review. Rachel, I'm just setting up the long story short in that when this is going up, say that dx dt is how far or how fast, how dx dt is how fast the foot is slipping. And y could be talking about the up and down measurement. So I would have my formula being x squared plus y squared is equal to, wait guys, how can I plug in 25? How is that legal? The ladder's not changing. Good, the ladder's not changing. If it says the top of the ladder, that top, y. Or they call it r or whatever, I don't care. And then the base of the ladder, that's talking about this changing. So d who dt? Oh, so they give me this, and then I'm trying to find that, and I have some such that's? Yes. I would go ahead and maybe think of 1/2 base times height. There's a few different formulas that they're going to ask, but that gives you at least an idea of where we're going. Does that kind of make sense? Take derivatives and plug and chug. Kiddos, I'll be here. Today's Tuesday? I'll be here during lunch. I'll be here during period 7 and after school for a bit. I can't promise super long, but I've extended the time so that 0 period tomorrow we can get some good work done. P.S. BC kids will love to tutor you on related rates. BC kids will tutor you. So maybe tomorrow morning be like, BC kid, related rates, come help. Or ask me and I'll force them. Well, strongly encourage. Bye, guys. They've been there, they've done it, and they like them. Ask for help.